Hello, and thank you for everyone for attending today's webinar called Key Database Criteria for Cloud Applications. My name is Reef Kassam, and I am the VP of Product at NeoDB. I will be hosting this webinar along with Matt Aslett from the 451, who is the Research Director for the Data Platform and Analytics channel. A couple of housekeeping items before we get started. After the presentations, we will have a brief Q&A period. To submit a question, please click on the question button in the webinar interface. We will try to get to as many questions as possible, but if we run out of time, someone will get back to you with an answer after the webinar. In addition, a copy of the presentation will be made available to all attendees and registrants. We also ask that you provide us with any feedback that you may have from today's presentations. With that, let's get started. Matt, please take it away.
Thanks, Reef. Thank you, everybody, for joining today's webinar. So, as we've said, my name is Matt Aslett. I'm the Research Director for Data Platforms and Analytics with 451 Research. Just briefly, before we get started on the presentation itself, to give you an introduction to 451, if you've not come across the organization before, so we are a leading IT research and advisory company. We were founded in 2000. We have about 300 employees, including over 120 analysts, and over 2,000 clients, which includes technology and service providers, corporate advisory, finance, professional services, and of course IT decision makers. And the last number I'll sort of read off here is the most important one, perhaps the next one on the chart, is 50,000 plus. That is the number of IT professionals, business users, and consumers in our research community. So those are not obviously necessarily direct clients of 451 Research, although many of them work for companies that are, but you know, they're practitioners, they're end users out there, you know, using technology either mostly in work or also at home, and they help shape our view on the world by taking part in surveys and interviews, and an increasingly important part of the 451 Research business. In terms of our research itself, so we deliver both, you know, written research and data across 15 channels. We talk about, you know, from the data center core to the mobile edge, and as you can see, almost slap bang in the middle there, data platforms and analytics. That's the channel that I am responsible for, and have been with 451 and covering data platforms and analytics for the last 9 years. So on to the you know, the content itself. When we're talking today, obviously, about databases as they relate to cloud and cloud applications. So primarily here, just to sort of set the scene, you know, in terms of our perspective on the cloud and how it relates to databases. I mean, you know, we obviously see that cloud is, you know, a significant trend. It definitely has an important role to play in driving down the cost of storing and processing data, and we've, you know, numerous research reports that point to that, and evidence from talking to customers and clients. We also see some additional benefits as well in terms of things like developer and business agility, faster time to adoption for emerging technologies, high availability, and reduced infrastructure configuration and management overheads. In relation specifically to cloud applications, and obviously we'll go into a lot more detail on this in the next couple of slides, but what we see is that cloud applications require a database that's able to deliver the combination of the flexibility and scalability advantages of the cloud, plus, you know, maintaining the sort of resiliency and functionality expected of a, you know, a traditional enterprise database. So if we talk about databases and the cloud, it's important, I think, just to level set what we mean by that, because there are multiple choices, and some people, you know, start talking about different parts of that, and you know, it's important just to be very clear. So if we think about this, I think, you know, a lot of the conversations initially we had with people around databases in the cloud and clients around databases in the cloud was databases on the cloud. So, you know, going back to 2008, the operational database vendors all made their, or pretty much all of them, they all have now, of course, made their products available on infrastructure as a service, predominantly, of course, at first Amazon Web Services, but then other service providers as well. And then the analytic database providers quickly, you know, followed suit in 2009. And, you know, so this has provided customers with additional choice. They can run those database products on the, you know, the infrastructure as a service offering of their choice. But what we're talking about here is really existing relational database products, and then obviously subsequently non-relational NoSQL database products as well, but existing products just configured to run on the infrastructure as a service environment. So you gain the benefits, obviously, of running infrastructure as a service, but, you know, in terms of the database itself, you're just running the database pretty much the same way you would on premises. Also, another thing a lot of people think of when you talk about database in the cloud is database as a service. So, there we're talking about on-demand delivery of database management software consumed by the user as a service. Predominantly, of course, again, we would think about public cloud with that, although it's not necessarily the case. I mean, we do see other organizations delivering private database as a service internally, either from their own, on-premises infrastructure or perhaps a hosting provider. Either way, we see that database as a service is in the very early stages of adoption, and most data-related workloads are deployed on premise and delivered in the traditional manner. And you can get a sense of some of the trajectory we see here from this chart, which is from our 451 Research Market Monitor Service. So we provide revenue estimates and market sizing estimates for all of the products and technologies that we cover within the data platforms and analytics channel. This chart in particular relates to operational databases, and as you can see here, so in blue is the revenue for operational databases as a service and databases on cloud infrastructure. And as you can see, whilst it's growing rapidly, it's a very small proportion of the overall database revenue. And so we anticipate that for operational databases especially, the majority of the revenue for the foreseeable future is going to come from traditional on-premises products. Primarily because that's where the incumbent adoption has been. But going back to the previous chart, there is a third option here, and that is databases for the cloud, or databases for cloud applications, as we've described it here. So essentially what we're talking about is a database that's designed to take advantage and enable that kind of elastic distributed architecture that supports software as a service applications. But that, whilst the applications will be delivered in a software as a service manner and consumed by end users as a service, the actual database software that underpins them may or may not be running in a cloud architecture. And if we think about the phases of adoption that we see from on-premises to all in cloud, that third option becomes increasingly attractive, because whilst we see that organizations are working towards cloud increased amount of cloud adoption, they're doing so in phases, through discovery and evaluation, running trials and pilot projects, application test and development, initial implementation, and broad implementation. And all of those phases in between could be described in some way or another as kind of a hybrid level of adoption. So what one of the phrases we've been using recently is hybrid is not a trend, it's reality. For most organizations that haven't yet gone all in cloud, which is the vast majority of organizations, hybrid is for the foreseeable future going to be a reality. And the reality is that even as they increasingly are delivering applications to be consumed as a service, the database that's running that, whilst it requires some of the capabilities to deliver that, things like elasticity, it may actually be running on premises in a more traditional architecture. So, one of the key factors here in terms of choosing a database for your future application requirements is to have that flexibility and the capability to move through these phases of adoption. In addition to that, if we think about the requirement drivers for databases for cloud applications, obviously the application itself is critical, and some of the capabilities in relation to the application, but we also talk about the developer requirements and the architecture. So to go through each of those in turn, if we think about from an application perspective, I'm not going to go through each of these things individually, but clearly, there's a trend in general towards, global, local, mobile, social applications. Essentially, an increased level of interactivity, which places in additional demands on the application that haven't been the case for more traditional applications delivered in a more of a kind of a client-server architecture. Additionally, a lot, if not, depending on the application, a lot, if not most of the adoption and access is going to be through mobile devices. Again, that just places different demands on the application and the database that is required to support it. Turning to developer requirements, again, there's multiple aspects at play here. Clearly, we talked about the requirement for additional flexibility. Clearly, agile development is a significant trend that we see is shaping organizations' choice of particularly in terms of their databases and their data platforms. A lot of access is driven now by APIs and REST, and then depending on the nature of the application itself, schemaless could be important. Clearly we do see an increase in NoSQL database usage, but in addition to that, SQL is not going anywhere. It hasn't gone anywhere. It's in fact increasingly important in terms of a means of accessing data and a means of querying data. In fact, we even see that obviously some of the NoSQL database vendors adding support for SQL because organizations want to retain their existing tools, their existing skills, and so SQL support continuing to be important. Then from an architecture standpoint as well, we already talked about the importance of distributed architecture, elasticity, scalability. Obviously, in recent years, there's been a big shift towards virtual environments, and then a more recent trend, towards containerization. So that those architecture changes plus the developer requirements plus the application requirements, you put those all together, and you start to really have to think seriously about the limitations of traditional relational databases. As we said, our enterprise architectures have shifted from a scale-up to a scale-out approach to make use of distributed hardware. There's greater scalability demands on the database layer than there's ever been before. And there's issues in terms of delivering predictable performance as you scale. We look at traditional, relational databases. They were never designed to cope with some of the modern application requirements. Things like geographic distribution, proliferation of cloud, the support for multiple data types. And all in all, what we see is that modern application requirements essentially require a rethink of the relational database model. Which isn't to say, you actually requiring to think beyond relational and throw away the investment in relational, but it's about thinking differently about the database products that are available and whether they can deliver you sort of the combination of the benefits of the relational model plus support for some of these new application and architecture requirements. So if we think about the key database criteria for cloud applications, there are actually many and multiple. So we've actually got them in two chunks here. So we start with scalability, dynamic, resilient, and simplicity. Scalability, the ability to scale out about low cost distributed commodity architecture. We've already talked about that. Dynamic, the ability to provision rapidly and scale up and down in response to changing requirements. Resilient, always available, and not just available, but available in an active form in multiple locations and multiple regions in order to deliver that global availability that we talked about earlier from an application perspective. And simplicity, despite all this additional functionality that you want, obviously what database administrators still want is simplicity rather than complexity, for that database to be easily monitored and managed and integrated with their existing applications and services. Beyond that, we see hybrid, performant, secure, and predictable as also key database criteria. Hybrid, we've already talked about hybrid cloud, but also hybrid in the sense of, we see an increasing demand from organizations to analyze data in the operational database, not as a replacement for an analytic specialist analytic database or a data warehouse, but as a quicker way of getting at value from that data as it is produced by the application. So we, people talk about HTAP and there's various different names. We talk about combined operational and analytic processing. From a performance perspective, whatever your database requirements. Performance never goes away. The ability to support high performance workloads as required. Obviously, some applications require greater levels of performance than others, but performance is always going to be a key consideration for any organization when selecting a database. So too security. Clearly never goes away, and obviously in relation to cloud applications, arguably actually more so top of mind, and we certainly see that amongst organizations when looking at cloud providers and cloud providers and architecture. Security is always one of the top 2 or 3 things they have in mind. The ability to support existing security and access technologies and standards is absolutely paramount. And then obviously the last one we put here is predictable. Again, this covers a couple of things. So I talked already about the ability to support existing skills and tools for organizations to bring their existing people and their skills to those databases. So for example, support for SQL. And then in terms of predictability as well, the consistency is clearly a significant issue. I haven't talked specifically here about ACID and ACID properties of databases, but clearly consistency is an overall requirement. That might be tunable, in some cases, depending on the application, that consistency might be eventual, but there is an absolute requirement for the database to deliver a level of consistency. So just to sum up, then in terms of sort of our core conclusions and the landscape as we see it, as we said, the growing adoption of databases on the cloud and databases as a service is something we do see, but hybrid is not a trend, it's a reality, and as we said, in terms of thinking about databases to support SaaS applications, it isn't simply a matter of choosing a database on the cloud or a database as a service. There are the other options in terms of an on-premises database with the architectural capabilities to support SaaS delivery. As we've said, we talked about some of the key requirements and the conclusion that we're seeing a lot of our clients reach, that traditional relational databases are not fit for purpose in terms of supporting a lot of their SaaS application requirements, because they were simply weren't designed to cope with those modern application needs. As I said, SaaS and cloud applications require a database that's able to take advantage of and also enable that elastic distributed architecture. And I think that's a key issue here. We're not just talking about the ability to run in a cloud environment. We're talking about the ability to deliver the kind of elasticity and distributed nature that organizations require for their SaaS applications. But of course, as we said, these things never go away. They also need to deliver the performance, resiliency, security, and some of the core functionality that's been expected of traditional, particularly relational databases, over the past 30, 40 years. So with that, I'll just thank you for your time. You've got my contact details here if you wish to contact us to find out more about 451 research. Obviously, I would also encourage you any questions to submit those, and we'll get to those a little bit later on. But for now, I'll hand you back to Arif.
Thank you, Matt. So Matt went through some of the core capabilities that he was talking about and seeing through his research. I'm going to just summarize a little bit from what we're seeing at NeuroDB when talking to customers. As Matt mentioned, customers are asking for the ability to do database cloud applications, to have a database for the cloud. And customers are saying they want elasticity. And when we hear elasticity, it's sort of conflated with a bunch of specific features, which is be able to run on commodity hardware across virtual or non-virtual environments, across a distributed platform, the ability to scale in and scale out on demand, the availability to have the system fully available all the time through upgrades, through outages, single server outages, etc., data center outages, so continuous availability. And for applications specifically that are sort of suited towards the SQL side, they don't want to lose SQL. They don't want to lose the ACID consistency model that they're used to. They want to have the ability to leverage the existing code and leverage the existing tools that have been built up around their application and not have to retrain their people or retrain or rewrite the code. And then also the ability to have a database system that manages their data as expected, rather than putting a lot of that data management logic into the application, which makes the application a lot more complicated. So customers are asking us basically that they want to be able to scale their SQL database to the cloud. And some of the benefits that customers are finding by going to the cloud through an elastic SQL database is sort of grouped into 4 topics. One is like customer satisfaction. Again, the ability to make sure that the database service and the application that it's serving is always up. There's no downtime. Again, consistent performance when they need it on demand. And again, the automation of making it simple to use, including automated disaster recovery failover. Customers are also looking at the time to market. They have existing applications that they've been either running on-premises at customer sites, and they want to provide a software as a service solution. So they want to reuse as much of the application that exists today using the SQL layer that exists, and trusting the data management layer to do the management that it was built to do. So making it faster for people to migrate off of on-premises to a SaaS model. The agility is critical, right? People go to the cloud specifically for agility, the ability to dynamically add and remove servers on demand, deploy across a hybrid environment or fully on-premises on a private cloud or in a public cloud or across both. And again, being able to have a SQL layer that allows them to have faster modifications to applications. And then finally, customers are looking for total cost of ownership, the ability to reduce their licensing costs, increase their server utilization to match their demand, reuse existing skills and tool sets that already live in the enterprise, and then be able to provision on demand without having to sort of certify large systems up front. And so with that, obviously NeoDB provides a single server database scale-out option for managing the databases. We were founded in 2010. The management team is database pioneers. There's a lot of database expertise within NeoDB. We have several patents around Elastic SQL database, and leading SaaS providers are running their solutions either in public clouds or private clouds on NeoDB. We're headquartered here in Cambridge, Massachusetts. And here's a few customers that are leveraging our application. So what makes NeoDB different? As Matt pointed out earlier, you need a database that was built for the cloud. And when you build a database for the cloud, you need to be distributed by design. You don't start with an existing client-server database application, put it into a cloud environment, and then try to add scale or add distribution to it through either sharding or through replication or through potentially a shared disk type of model like some database companies provide. So you don't start with an existing database and host it and put it on the cloud and then try to make it scalable. You start with a database that was built for distributed systems. That is a peer-to-peer environment that scales across nodes, across different types of servers, across locations, but is still a single logical database that can scale elastically. The second key idea is a separation of duty, right? We're finding this more and more in the computing space, where you have the separation of processing and storage. And so with NeoDB, we've got 2 layers, 2 different types of processing that we provide that can be scaled independently. We have our transaction engines, which basically is supporting transactions in memory with an existing working data set. There's no explicit sharding, there's no explicit partitioning, but clients, automatically by the workload that they send to the TEs, dynamically partition the data into the working data set that they use, so it stays in memory. The scale and throughput is dynamic by adding additional TEs allows customers and clients to scale their application workload. All these features from an application perspective is transparent, right? The application is unaware of the number of TEs or the locality of the TEs that they are talking to. The second part of the architecture is the storage, right? Obviously, a database needs to be durable, right? And so we can allow the processing of durability separate from the actual processing of the transactions. And you can have a tunable consistency model here by either making synchronous or asynchronous in terms of how the data is stored, and they can be specified by region. You can have synchronous locally and asynchronous remotely. So what this does provide is a single logical database that allows multiple processes to be used in different combinations and permutations depending on your workload. For read and transaction-heavy workloads, you can scale out the transaction engines. For write-intensive workloads, you can scale out the storage managers. Any one process, failure of any processes has no effect on the application. They survive both failures. And you can also allocate different server types based on the type of processing you need. You could have memory-heavy transaction engines or disk-heavy storage managers. You can mix and match. We don't really care the type of servers that you use and leverage commodity or specialized hardware. So in practice, this is it's a little busy diagram, I apologize, but in practice, this is sort of showing you how applications may connect up to the various systems. The green dashed box represents the TEs and SMs that are in a peer-to-peer network that are talking together. The applications are either connected to one or more TEs, and in this case, if the TE fails or goes away, whether that was in a transient virtual container that went away, the application simply redirects its queries to a surviving TE and continues on with its transactions. And the plus signs to the right of the X's are indications that you can dynamically add additional nodes, whether that's the TEs or storage managers, and the applications can dynamically scale in any manner as well. So we support fully redundant, elastic scalable, continuously available, and active-active across single data centers or multiple data centers, multiple availability zones. So here are some typical deployment scenarios that we see with customers. Customers typically start out with what we call a fully redundant single data center environment where they've got a 2x2, so two TEs and 2 SMs for full redundancy and processing. We also have the ability to add additional SMs. In this case, the middle image is with a snapshot manager to account for logical errors, so be able to take snapshots and revert snapshots automatically for logical errors or fat finger errors. And then obviously scale out. So customers then, once they're comfortable with the deployment that they have and the application is meeting their SLAs, and as the application SLAs or application workload grows, you can scale out the different engines, whether it's the TEs or SMs, dynamically as needed. From a multi-data center approach, we also support obviously disaster recovery. So the disaster recovery could be a hot standby, depending on your usage. So there's a primary site where all the applications are being driven, and then you have a disaster recovery that's what we call hot standby, ready for processing as soon as the application switch over. So there's no recovery time, there's no outages once the application switches over to the DR site. We also do support active-active, so the ability to run applications across multiple locations, in this case across multiple availability zones or low latency or limited latency regions that are in close proximity. And we are scaling out to multiple regions, so two or more regions that are separated out with longer latency links for larger regional distribution of data centers. So in general, how we position NuoDB across the landscape of your options for cloud deployments, you have the SQL layer, so the consistency, the durability, recoverability. Obviously, the traditional databases score very highly on that axis. And then as you move out to the cloud and new SQL or NoSQL, the SQL capabilities decrease as you move across there. And then on the elasticity side, which includes simplicity, continuous availability, and scalability, the traditional databases score low on that, obviously because they weren't built for that. And as you move out to the right, the new types of databases scale much better from an elastic perspective. We position ourselves high both in the SQL category as well as high in the elastic category. Obviously, we're fully ASLET, so we support all the SQL semantics and provide full elastic capabilities across multiple distributed compute environments, locally or remotely. Shown here is also a quote from one of our customers, Kodiak Networks. In this case, they selected NuoDB because of the choice of supporting scale for their transactional application that they had and that they needed. So in summary, NuoDB provides an elastic SQL database. It is, in our belief, the only database that allows scaling out to the cloud for your SQL applications. You don't lose the benefits of a SQL or relational database by moving to the cloud. It also provides continuous availability with disaster recovery. Allows you to concentrate on your business, reduce your costs, improve your customer experience, and get faster to market by moving to the cloud as quick as possible. That is the presentation. So both presentations, we've got 15 minutes or as much time as we want for questions and answers. So if you have questions, please go to the questions box in the webinar and add any questions that you may have to that, and we will answer them as we see them. So, Matt, I think there's a question for you here. When should customers consider using NoSQL versus a database built for a distributed RDMS database for the cloud, also known as sort of the new SQL systems?
Sure. I mean, obviously there's multiple kind of reasons for going NoSQL or a new SQL. Sometimes it may come down to the data formats. Obviously, it depends what you're trying to achieve in terms of if a particular requirement may take you towards say for example a graph database or a very simplistic requirement of a key value store. Ultimately, though, I think what we see organizations looking at is unless they've got a very specific requirement that takes them in a specific direction at a higher level, it's really about the consistency requirements. I mean, I touched on consistency. You talked specifically about ACID requirements. Clearly, if the requirement is ACID, then you're looking at a relational database. Obviously, if you're looking for distributed, you're looking towards what we would call a new SQL database. Yeah, so I mean, there are multiple drivers. Actually, we're just in the midst of publishing a report about this, kind of the way you should think about the choices that you have for different database application requirements, and we're looking at least 7 in terms of that. But I think consistency and ACID consistency is one of the primary ones, in terms of that choice.
Excellent, thanks, Matt. So here's another question here. Does NuoDB support distributed transactions? So I'm not just to be sort of clear. NuoDB is a single logical database. So even though it is a distributed engine by nature, from an application perspective, it's a single logical entity. So the application doesn't really need to worry about distributing transactions across the different nodes. We have within our environment the ability to understand the data cache and the existing state of the database, the consistent state of the database. It is an MVCC database, so we have multi-version concurrency control. There isn't really there isn't a need to support distributed transactions because it's a consistent model across all the engines. I hope that answers the question. Just looking through this here, the rest of the questions here. Is there a possibility to use NeoDB as a managed service? Are there any providers like AWS? So that's a great question. Today, there isn't any managed service providers providing NeoDB as a service. You can run NeoDB in AWS. Some of our customers are running it in AWS, but currently there is no service as a service option. So there's another question here. How many active geographical regions can you have where the inter-region connections are slow? So because we're a consistent database, a fully logical consistent database, and we can't break the speed of light barriers, having low bandwidth or long latency links between your regions will impact how fast the consistency information is shared across the environment. And if your durability requirements are strict in that the data needs to be durable across multiple regions, then by nature you will pay the penalty. The applications will pay the latency penalty. So what we provide with NeoDB is a trade-off. You have to decide what your trade-off is, whether that's durability across multiple regions for the data or performance in terms of latency for those transactions. Just looking through the rest of the questions. Does NeoDB have encryption as part of its engine? Yes, we do. So all the data is encrypted at the network layer. We do not encrypt on disk. But that can be easily solved by third-party encryption engines at the disk layer. So lots of questions. Just trying to make sure I get to some of these. What's the security? So another security question. What's the security on NeoDB? Again, it's a standard database, so we've got access controls on users. The data, the network data is encrypted, but as I mentioned, we don't encrypt on disk. There's a question about the recording. We will provide information about the recorded webinar to all registered participants. There's a question here about how hard is it to migrate SQL applications from SQL Server Oracle to NeoDB. So as we are building out our SQL layer compatibility, so we support ANSI SQL today. Obviously, each database vendor has its own proprietary extensions. We are actively migrating a number of SQL Server instances to NeoDB, and it's becoming easier and easier over time with those migrations as we sort of fill out our compatibility feature set across those different databases. Just going through here. Matt, here's a question for you. Are customers looking to use cloud as an augmentation to on-premises resources, or for existing applications, or for new applications?
Yeah, I would say, I mean, primarily we see it's driven by new applications. I mean, you can and will find obviously examples of customers that are migrating existing applications across to different databases running in the cloud. You know, what we see is, you know, just traditionally, people don't change their database unless they've got a really, really good reason to do so. What they do is they select a new database for new applications, and they develop those applications, and they then at some point retire the older, you know, applications and the database that goes with it. So that's what we see predominantly going on. Absolutely.
And I think this question is also could be answered by you, and maybe it's a combination here, right? Do we feel that rolling back software upgrades is easier in the cloud now? So I don't know if you have a view on that, Matt.
Yeah, well, I think theoretically, I mean, I think, you know, the devil's in the details, isn't it? But yes, I mean, theoretically, there could be some advantages to that. And I think it depends on precisely what software you're using and the functionality that's available. But certainly in some products and services, we've seen that, you know, there is that advantage.
Yeah, and from a NeoDB perspective, rolling upgrades and rolling downgrades are critical to us. So we support the ability to take a particular node offline, upgrade it to the next version, bring it online, and do that across the different topology. And obviously, the rollback is the same model, right? You can roll back different parts of the environment over time so that you're not stuck having to take an outage. There's a question here about pricing. Is NeoDB for free? We have a community edition that is available for free for download off our website. The non-community edition, the enterprise edition, is a licensed model. There's a question about interfaces. So does NeoDB provide a programmatic database interface? What languages does it support? So obviously we have a standard JDBC, ODBC interface. We have had, we do have other interfaces that are sort of community-led, Python and others. There is a GitHub page that has some of those drivers available for use. There's a question here. I'm not trying to interpret it, but the question is, where's the data stored? Is it in the U.S. data centers? So we provide a solution that customers deploy, whether they deploy it on their own premise, their own data centers located in the U.S. or internationally, or they deploy it against a cloud provider, whether that's AWS or somewhere else. So NeoDB is not hosting the database as a service. We are providing a software solution to enable a database as a service, or to enable a software as a service for your applications. Lots of questions. If you have any more, please, again, just submit them through the questions and answer box. I'm just going through, making sure we've covered most of them or all of them. So here's another one, sort of similar to the cloud question here. What cloud environments does NeoDB support? So today we have support for AWS as well as private cloud environments. We are looking to support Azure and Google Cloud environments in the future. Here's another question here. Does NeoDB support hybrid deployments that span both on-premise and cloud environments? Yeah, so again, because NeoDB can span multiple availability zones or data centers, you could have NeoDB running on premises and a cloud provider and cloud provider that's fairly close by in proximity that has some of your nodes, so you can have outages either in your data center or the cloud and still survive that from your application perspective. So that's sort of what we call, it's a different type of hybrid model, which span multiple data centers or multiple environments, and we do support that. I think that's most of the questions. If you have any other questions, please feel free to ask that in the Q&A box. There's a question here. Does this make us more trigger happy with upgrades? Again, I think this depends on your application and your cycles, your upgrade cycles for the application. Obviously, for software as a service, one of the biggest benefits of software as a service is the ability to do the upgrade in place, and the customers don't know that the upgrade is actually happening or really care that the application is happening. So again, depending on your application level deployment models and how you schedule those, I think you move into sort of the whole DevOps model where with every build you're pushing to production, right? So we know people who are doing that every 2 weeks. Obviously, Amazon does that very regularly as well. So again, I think it depends on your application, how it's been built and how you're deploying your application. So I think we'll take one more question here. Is cross-region supported today on the roadmap? So cross-region, as I sort of showed in my slides, is something that we're working to, and we'll have our plan is to have something shortly. I can't commit to it right now, but it's cross-region or long latency. In other words, long latency distributed data centers is something that we are actively working towards. So I think that's all the time we have for questions today. On behalf of myself and Matt, I'd like to thank you for attending today's webinar and hope to see you on another webinar soon. Thank you and have a great day.